So we're now going to take a look at the source code for the PrimeChecker app, and we're going to start out with the server part. You can see here that it's in EX1, which stands for example one. And down here, you can see we have a source folder. In that, we have main. We also have test. We have a bunch of packages under that. And we're going to start by taking a look at the server side. And we'll begin with the PrimeCheck application. And this is a very common starting point for any kind of Spring-based server or microservice. And this class called PrimeCheck application provides the entry point into the Spring WebMVC-based version of the PrimeCheckApp server or microservice. It's actually could be either thought of as a service or a microservice. We only have one of them, so it's not really microservices in the fine-grained sense, but it basically plays the role of a server. And you can see here a couple of annotations to start off. We have something called Spring Boot Application, which enables this app to use various Spring features like auto configuration, component scanning, and also to define some extra configurations on the application class. And this is all part of what's known as dependency injection. And I'll show you specific examples of that in like the next file. There's also this thing called property source, and that basically points us to a property file that's used to configure certain properties of the server. This server properties is defined in the constants utility, or it's part of the common constants file. And you can see here that we define the server properties to be in server-application properties. And if you go over here and you look into the resources folder, you'll find server application properties. And we basically give it the name. It's a very boring name. I just call it server. I should probably call it something more interesting like Prime. Let's call it PrimeCheck server. That's a better name. And then we also tell it we want it to listen on port 8081. So we don't have to write that ourselves. Okay, so popping back out of that for just a moment and going back over here to PrimeCheck application, what you can see PrimeCheck application does is it just defines a main entry point. That's, of course, what gets called to launch the server. We take the argv parameter that's passed to main. This is standard Java. We parse it with our options singleton. This is something that we wrote. This is part of the utils folder, so options. We'll look at that a little bit later. We can use that to set certain properties we want the server to be aware of, like whether debugging is turned on or not. And then we go ahead and we say Spring application run, and we pass in the PrimeCheck application class. And that's where everything starts, right? So all the wheels begin taking motion at that point. So dependency injection is performed, component scanning is performed. A lot of things happen at that point. For our purposes, the most important thing that happens from the server point of view is we basically initialize the PrimeCheck controller. And this is just a term of art you'll have to get familiar with. Everything in Spring is based on controllers. Think of it as basically a way of connecting or bundling together a bunch of endpoint handler methods. And you'll see what those are in a second. And this particular controller is going to demonstrate how we can handle HTTP GET requests, which you actually never see as a programmer. That's hidden from you by the Spring framework. And we're using Java parallel streams, as you'll see in a moment. And basically, the requests that come in from the client are going to be mapped to these implementation methods or these endpoint handler methods that will determine the primality of large random integer objects. And you'll get a chance to see more of that in a second. There's some other documentation here, which I will not read through in detail. You're welcome to look at it. It just talks about how Spring works. It's meant to be used for so-called RESTful programming. And so it supports operations like GET requests, POST requests, PUT requests, and DELETE requests. And we'll see how that works in this case for GET requests, but POST requests and DELETE requests and PUT requests are also handled in a very similar way. And the way that we identify this class as being something that will handle HTTP requests in a RESTful manner is by using the REST controller annotation. So this is an instruction to Spring to treat this particular controller in a special way and to auto-generate a whole pile of code. We'll also see that we use the GET mapping down here. Take a look at the methods we have. You see GET mapping. And GET mapping basically says this endpoint handler method will handle the corresponding GET request. And we'll see how those things get connected together in just a second. And that allows us to be able to send requests from a web browser or from command line utilities like curl or postman, or in our case, we have a client application that we run as a test driver that generates these requests. And then finally, we put this other annotation here that's called response body. And that just tells the controller that objects that are returned from the endpoint handler methods will automatically be serialized into JSON, which is a format for encoding very basically native types in a text-like format, and passed back in the body of an HTTP response object. So once again, we don't see HTTP GET requests per se. We don't see HTTP responses per se, but that's what's happening under the hood. We're programming at a higher level, and you'll see in a minute why you want to program at that level. So here's the PrimeCheck controller. You'll see that we have an interesting field here that's called PrimeCheck service, and it's auto-wired. Auto-wired is a special annotation that is used by Spring and its so-called dependency injection engine to automatically connect the PrimeCheck controller, this class, with something called the PrimeCheck service. And we'll take a look at PrimeCheck service here momentarily, but this is where the actual business logic gets run. The PrimeCheck controller is what handles the transformation from HTTP requests, in this case, GET requests, into things that can be forwarded to the underlying service, which does the implementation. I'll talk about that more in a bit. This is a very important distinction, though, between the handling of HTTP requests as they come in and then the actual implementation. And that's why we have a controller, which is what this file is, and a service, which we'll look at in a second. So as you can see here, very well documented as always. So check if prime is just the name we give this endpoint handler method. What's really important is this get mapping. And if we go look at this, you can see that it's just /check if prime. And that's going to be information that's going to be added to the URL that will be passed as a GET request to the server from the client. So check if prime is just /check if prime. That's what's actually sent in the GET request at the HTTP level. But when we receive this at the Spring programming level, Spring WebMVC level, it's going to be turned into a method call with a single parameter called PrimeCandidate, which is of type integer. And you can see all it does is it prints out a debugging string if debugging is enabled, and it just forwards to the underlying service. So when someone sends a GET request over here, as we'll see in a moment when we get to that part, it forwards to the implementation check if prime. And if you look at the implementation of check if prime, it's defined in the PrimeCheck service. And the PrimeCheck service, by convention, is the class that defines implementation methods that are called by the PrimeCheck controller. So you can see a very nice separation of concerns here. PrimeCheck controller handles the transformation of GET requests to Java method calls and doesn't really do much work. The PrimeCheck service, in contrast, doesn't know anything about the HTTP requests, and it only knows how to handle just requests with Java types doing Java things. So that's the separation of concerns. So this particular class is annotated as a service, which enables auto detection and wiring of dependent implementation classes by what's called class path scanning. And that's what's done up here with this auto wired annotation. It says, get me an instance of PrimeCheck service and auto wire it together. We'll talk a bit more about that in a second. So check if prime does an obvious thing. It takes the PrimeCandidate, which at that point is a Java integer. It calls a helper method called isPrime, and isPrime just does a very brute force algorithm to determine whether or not a PrimeCandidate is a prime number. If it is a prime number, we give back the value 0 because there's no factors that can multiply it in order to be able to get that number, or divide it, I guess is a better word. And if it's not a prime number, it'll give back the smallest factor. So that's basically what isPrime does. And again, it's just designed to burn CPU time, not meant to be very efficient. We print out the results if we have debugging enabled, and then we return the result. So I think you'll agree with me that checking if a number is prime using Spring is just a piece of cake. This looks like good old Java code. You don't see any hint of HTTP requests or annotations per se. You just see a method that takes a request and makes a method call to check if the number is prime. Going back to the controller method, the controller class for a second, there's another class here, which is called check if prime list, or another method called check if prime list. And you can see here that check if prime list, unlike check if prime, takes a list of integers, which we call prime candidates. And as you can see, whoops, this is the controller version, sorry. Here is check if prime list, and it takes a list of integers, and it also takes a Boolean flag that indicates whether or not we should do parallel streams to compute the result. This check if prime is also an endpoint handler method, and we define this check if list prime constant to be / check if prime list. And that's what, of course, will be encoded in the URL to get us to this endpoint handler method. As you can see, we have to put an annotation here because list is not a primitive type, whereas Boolean, integer, string, those are primitive types. We don't have to encode them in any special way. But if something is a list, it's not a primitive type anymore. It's a list of primitive types. So we have to apply a request param annotation to indicate to Spring to treat this in a special way. And what will happen here is we'll take this list of integers and the Boolean, which is the parallel flag, and we just forward that to the underlying service and its check if prime list method. And just like we did before, if we look at the implementation, this takes the list of integers and the flag, and then it does some Java parallel streams magic. And this is actually really cool. So check out what it does. It first goes ahead and prints out a diagnostic, which I probably should be a little bit more consistent here in printing this out, but that's okay. That's fine for now. We create ourselves a stream from the list. So we have ourselves a stream, which is a stream of integer. And then we conditionally convert that stream, which by default starts out as a sequential stream, into a parallel stream. So if the Boolean is enabled, if it's true, we turn the stream to a parallel stream. And then in either case, either with a sequential stream or a parallel stream, we take the stream, we call the map transforming operation on each element in the stream, each of these prime candidate integers in the stream, and we check to see if each one is prime or not. And of course, what that gives us back is a stream of results, which will either be 0 if the number is prime, or the smallest factor if it's not prime. And then we collect that into a list. So we get a list of integer results as the result. And then we go ahead and conditionally display the results, and then we return the results. So you can see the results are going to be displayed, or sorry, they're going to be returned here as a list of integer. And we don't have to do anything special to the list of integer, because over here we said everything that comes back is going to be encoded in the response body in an HTTP response object. So all those things get stuck in there appropriately using that annotation. So that's basically the server-side code. The key things to remember: here's the application that kind of launches everything. Here's the controller that knows how to take these incoming HTTP GET requests at a lower level and then demultiplex and dispatch them to these endpoint handler methods. And then those forward to the implementation methods defined in the service, which just do their thing. And you can see here when we pass a list of things, list of prime candidates doing their thing, could run as a sequential stream, could run as a parallel stream. That behavior is controlled by the parallel parameter, which you'll see shortly is actually passed from client to server as part of the HTTP GET request.